So the problems you just worked on in your warm-up were a very common type of math counts problem. This problem that asks you to count the number of shapes within a larger composite figure. So it's definitely something you're gonna run into as you work through your handbook or go into competitions. And the most important thing when approaching these problems is having a organized method for your counting. You can't just go in and start counting randomly because you might easily miss one. So the method I like to use to do my counting is to start with the smallest element first, an element that's not composed of any other shapes, and then kind of work up from there, building with the smaller elements into larger shapes and counting as I go. So we're going to look at a couple problems using that method and then let you go ahead and try that same organizational method on some other problems. So the first problem we're going to look at says how many triangles of any size are in the Belgian truss shown. And don't worry about knowing what a Belgian truss is. Essentially it's this shape, but that's just the official name. It's not something you're going to need to know later down the line. So the first thing I'm going to notice about this before I jump into my counting is that it's actually a symmetrical figure. So what I'm going to do is just divide it right down the middle to start, because I'm going to realize that whatever I count over here can just be doubled. It's going to occur over here as well. So we're going to start by counting the triangles only on this side and then doubling them to get the triangles on this side. So I start from the smallest element, like I said, so I'll just look at a single triangle. So here's a triangle over here, and it's just one triangle all by itself. It's not composed of any other shapes. So I'm going to count every triangle that is one triangle alone, and I get 1, 2, 3, 4, 5, 6. So there's 6 triangles that are composed of only one triangle. Next, I'm going to move on to triangles that are composed of 2 triangles. So if I go ahead and look, the first one I'm going to look at is, if I color this in, this triangle right here. All right, so then I'll just keep moving up and I'll look at these 2. Well, those 2 I see have 4 sides. Okay, so I'll look at these 2, again, 4 sides, these 2, 4 sides, these 2, 4 sides. So really it's only one single triangle that's composed of 2. So we get +1. And we're going to continue that pattern. So let's look at 3 triangles. So if we look at this one, we get 1 triangle there, and similarly to the 2, I'm going to keep moving up and looking at these 3 together. That doesn't form a triangle. These 3 together doesn't form a triangle. These 3 together doesn't form a triangle. So just like the 1, there's only going to be 1 triangle composed of 3. So we can continue this pattern for 4 triangles here. So 1, 2, 3, 4. Similarly, that's going to be just 1. 5 triangles, and then 6 triangles. So in total for this one, on this half, we have 6, 7, 8, 9, 10, 11 triangles total. And like I said, we can just double that, and we know that every triangle we counted over here, the mirror image is going to occur on this side, so we have 11 over there as well. So in total we counted 22. But that is not the final answer. What we have to look at now, since we did divide that shape in half, is there any triangles that can be created that cross over this line of symmetry? So if we start from the middle and kind of work out, if we look at these 2, we see we're going to create a 4-sided figure. And similarly, as we kind of work out, if we added these 3, that's not going to create a triangle, that's not going to create a triangle. And we realize the only one that we didn't really count is the larger triangle that is the entire figure. So we just need to add +1, and we get our final answer of 23. All right, so let's look at one more sort of similar. We're going to be counting triangles. So this one says, how many triangles of any size are in the figure shown here? So before we jump in, let's use some of the knowledge we got from the last one and look at this figure. And if you notice, it almost looks like it's two of the same figure, just kind of shifted. So if we kind of cut this figure right here, we realize that this is identical to this. And we're looking for triangles. So unlike this one up here, where the entire thing created a triangle, we need to count that. This one, there's no triangles created between them. If you look at the only two portions of the figure that touch, create this sort of rhombus diamond shape here. So really, we can just completely ignore this second shape for now, count the triangles in here, and double them. So it's gonna make it a little easier for us. So let's start again with triangles that are composed of just one single triangle. So if we count those, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 of those. All right. And then let's move on and we can see if we can form any triangles composed of 2. And you'll realize as you kind of look through this figure, it's all 2 equilateral triangles together, and anytime you add those 2 together, you're getting this diamond shape. So there's no way to create a triangle with 2 elements. Similarly, if we look at 3, that's also not going to give us a triangle. So let's go ahead and look at 4, and we can actually create another triangle using 4 of these smaller elements. So now let's count how many triangles there are made of these 4 triangles. So there's obviously this one here, and then if we kind of shift that down here, we can find there's another one down here, so that's 2, and then we can also find another one over here, so that's 3. We can continue to count, but if you notice, this triangle pattern is just almost flipped. So these same 1, 2, 3 triangles that we just counted are also going to occur here, here, and here, just upside down. So we really have 6 that are created of 4 triangles. All right, so the last composite that we can really create is going to be made of 9 triangles, and you can check me on this, but if we start adding, and we have 4 here, if we get to 5, there's no way to add 5 together to get a triangle. 6, 7, the only way to get to it is to go ahead and put all 9 of those triangles together. And if we see that, we have this one larger triangle here, and again, the mirror image of it here. So there's 2 of those. So in total, we have 20 triangles in this figure, but again, we want to double all of that to get our total answer of 40.